So, you are welcome back to this series. At the last class, we stopped at the nomenclature where I make mention and analyze the rules that guides the naming of compounds. And I give you those ones and you can get them without stress. I've given you that the first you need to get the longer chain, and you also consider the branch chain or the archaeal attachment. But today, majorly, I will emphasize more on how to name the compound. Then in this regard, we are going to work on isomerism. Now, when you're talking about isomerism, we are talking about occurrence of compound. Two or more compounds having the same molecular formula but different structural formula. They have the same molecular formula but different structural formula. So I'm going to write isomer of each compound. How many compounds can we get and how can we name them? Under from 1 to 10, 1 carbon to 10 carbon, as God will help us. Let's start from the first one. Number 1, we have methane. Don't forget the formula of methane is CH4. Let's look at it. Can we have any? We have 1 carbon and how many hydrogen? 4 hydrogen. And this is the only structure we can have under methane. So, and that is the name still remain methane. No other attachments or any other change of names. So let's look about the second carbon. We have ethane. Ethane, remember, is C2H6. Let's see the structure we can write under that. We have C, we have 2 carbons, then we have hydrogen. Ensure that all carbon is a saturated carbon. So in this one we have 6 carbon, we have 1, 2, 3, 4, 5, 6. So this one cannot be rearranged more than this, and the name still remains ethane. So let's go to the next one. 3 carbons. We call it propane. And that was C3H8. Let us see if we can have a different thing about that. We have 1, 2, and 3. Then we have this to it. Then we have this. We have 1, 2, 3, 4, 5, 6, 7, and 8. This one still remains propane. In this regard, even if I try to generate another isomer here, we will not really generate another isomer. How do you generate it? There's just the placement of this carbon. Let's move further. We have C, C, C. This carbon is a straight one. Let's assume that we put it here. We put it like this. You still have 1, 2, 3, 4, 5, 6, 7, and 8. If we are going to count it, we still count 1, 2, 3. So it still remain the same. It still remain propane. So let's go to 4 carbon. From there we can deduce some isomers from there. So let's look about butane. Butane, we have C4. We have C4H10. We have straight chain first, 1 and 4. Then this will give us what? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this one is called butane, as the name has been written. Then we can have an isomer from this. How do we get the isomer of this one? We have 1, 2, 3. Then I can make this carbon to shift to this side, become this. Then they still give you the same number of hydrogen. If hydrogen numbers is not complete, that means your formula, your structural formula is not correct. So let's have it 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, how do we name this one? Let's quickly see. Look at this. This attachment on the second one, 1, 2, 1, 2, still on the second one, so we can name the carbon from anywhere. You have it on the second carbon, and what is attaching is what? Methyl, because it's not complete for hydrogen, and that is what we call a carbo. So in this regard, we call it 2-methyl, and what is the longest chain? 1, 2, 3, and that we call propane. 2-methyl propane. Then on butane have only 2 isomers. Not that one. If I adjust this one to this one, still give us the normal butane. So I will continue in the next series for explanation, so that I will not bore you all for explanation. Thank you.
Okay.